It's hard to believe, but it was only back just a year and a half ago in mid-2022 that we had yet to encounter the very first science images released by James Webb. Astronomers have made an unexpected discovery using the James Webb Space Telescope. It spotted 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang that created the universe. In the time that's passed since, we've got a revolutionary glimpse of our universe, replete with tremendous new discoveries: the farthest black hole, the most distant galaxy, the farthest red supergiant star, and many other cosmic record breakers. That's extremely impressive, but James Webb, as told, was built to enhance the effort to understand not only what our universe is and how we fit into that cosmic story, but also the story of how the universe evolved and grew up to be the way it is today. Thus, despite presenting a series of astounding upgraded images unveiling our universe in unprecedented clarity, James Webb now continues to try to lift the veil on the secret of deep space, helping us refine our own story. A story of our origins and how similar and different we are to the rest of the universe. Join us as we dive into some of the recent stunning discoveries of this scientific goldmine using NASA's James Webb Space Telescope. Failed star aurora. Astronomers have spotted a failed star or brown dwarf that shows signs of possessing an aurora. Auroras are more familiar as the northern and southern lights, which are caused by charged particles from the sun striking molecules in Earth's atmosphere. They're usually seen only at high latitudes because our planet's magnetosphere funnels these particles toward the poles. Auroras have been spotted around other planets in our solar system, such as Jupiter and Saturn, and even over active moons like Jupiter's Io and Saturn's Enceladus. All of these light shows are likely caused by bombardment by charged solar particles. So, the newfound apparent aurora around the brown dwarf designated W1935 and located over 40 light-years from Earth is mysterious. There are no stars close to it that could be providing the charged particles to fire it up. Brown dwarfs are larger than gas giant planets and smaller than stars, but form like stars due from a collapsing cloud of gas and dust. That means that most brown dwarfs are often isolated from stars, just like W1935. They get their slightly unfair nickname, failed stars, because they don't have enough mass to trigger the nuclear fusion of hydrogen to helium at their hearts. The potential aurora over W1935 was indicated by infrared emissions from methane spotted by James Webb. When methane emissions like this are seen over Jupiter and Saturn, they are the result of atmospheres being heated as charged particles whip down magnetic field lines and hit atmospheric particles, also creating auroras. So, the study team thinks that the same applies to this isolated brown dwarf. With a lack of an external solar wind to cause the brown dwarf's likely aurora, the team believes that there may be some internal process occurring within the brown dwarf supplying energy to its atmosphere. Alternatively, interstellar plasma could be striking W1935, or the brown dwarf may not be totally isolated and could be receiving an influx of particles from a nearby active failed star. Methane moon. The team of scientists led by American Museum of Natural History astronomer Jackie Faherty made the discovery while investigating 12 brown dwarfs with James Webb. Among these were W1935 and W2220, two very similar brown dwarfs that the 10 billion telescope found were near clones of each other, sharing similar temperatures and brightness, as well as near-identical composition of water, ammonia, carbon monoxide, and carbon dioxide. However, W1935 differed from its near twin in having methane that was emitting infrared light. On W2220, the same chemical compound was absorbing light. As Faherty said in a statement, "We expected to see methane because methane is all over these brown dwarfs, but instead of absorbing light, we saw just the opposite. The methane was glowing." My first thought was, what the heck? Why is methane emission coming out of this object? Modeling the atmospheres of the brown dwarfs to determine the cause of the methane emission, the team found that the atmosphere of W2220 cools with altitude, but the atmosphere of W1935 seems to be experiencing a temperature inversion that sees its atmosphere heating up at higher altitudes. According to research lead modeler Ben Birmingham of the University of Hertfordshire in England, This temperature inversion is really puzzling. We have seen this kind of phenomenon in planets with a nearby star that can heat the stratosphere, but seeing it in an object with no obvious external heat source is wild. That led the team to turn to Jupiter and Saturn for an explanation. Finding temperature inversion is prominent in the atmospheres of these solar system gas giants too. The leading theory for this is heating by the same process that is creating an aurora. Auroras have been used to explain unusual qualities of brown dwarfs before, such as radio emissions from warmer examples of these failed stars. However, the Webb telescope observations of W1935 represent the first time that methane emission from a brown dwarf has been spotted, indicating an aurora. As Faherty concluded, with W1935, we now have a spectacular extension of a solar system phenomenon without any stellar irradiation to help in the explanation. With the James Webb Space Telescope, we can really open the hood on the chemistry and unpack how similar or different the auroral process may be beyond our solar system. Physics. Another remarkable finding: physics-breaking rogue objects spotted by James Webb are emitting radio signals rarely seen from other worlds that scientists can't explain. The rogue planets spotted by James Webb lie in the Orion Nebula, a long-time observational hotspot for astronomers. In total, they number over 500. This discovery bonanza was possible thanks to Webb's ability to pick up infrared radiation emitted by these relatively young planets. Bizarrely, about 80% of these planets exist as pairs similar in mass to Jupiter. The planets orbit each other at distances ranging from 25 to 400 times the distance between Earth and the Sun. These tangoing duos, called Jupiter mass binary objects or jumbos, pose a huge mystery for astronomers because the existence of these worlds challenges current theories of planet formation. Some scientists think these objects may not even be planets, but rather previously unknown entities that are larger than planets, but smaller than brown dwarfs, which are sometimes called failed stars because they blur the line between planets and stars. Webb's data showed that jumbos generated infrared radiation, but the new study's authors wanted to see if these dancing objects produced radio waves. That's because different classes of cosmic objects produce distinct patterns of radio emissions. For instance, planets like Jupiter spew several types of radio signals, including gigahertz frequency emissions, thousands of times higher pitched than an FM signal, partly because of their magnetic fields. Notably, spotting such signatures from the jumbos could help resolve their identity. As lead study author Luis Rodriguez, a professor emeritus at the Institute of Radio Astronomy and Astrophysics at the National Autonomous University of Mexico, said, "The observations could also explain why some objects have detectable radio emission and others do not." To find radio wave snapshots of the Orion Nebula, where the jumbos reside, the scientists combed through archives of observations maintained by the U.S. National Radio Astronomy Observatory. They found just one pair that apparently emits radio waves, Jumbo 24. Itself an oddity among the oddball objects, it's the heaviest of the jumbos and also the one with the tightest space between its component planets. A decade's worth of data the research team curated showed that the radio waves remain steady but strong, with a power of roughly a quart of a ton of TNT and frequencies of 6 to 10 gigahertz. The radio waves also weren't circularly polarized, meaning they lacked spiral twisting electric fields. But these features aren't what astronomers expect of signals created by planets. As Rodriguez said, circular polarization is an unambiguous indicator of the presence of magnetic fields. Without this, the team can't say definitively that the signals come from Jumbo 24. Besides, radio emissions from other exoplanets are more variable and less intense. Even if Jumbo 24 isn't a pair of planets, but rather another type of cosmic duo, the signals are unusual. Signals from brown dwarfs are very different from the newly identified radio beam. The beam's brightness and frequency even ruled out the possibility of pulsars, the rapidly spinning cores of dead stars that produce pulses of radio waves at regular intervals. The researchers also estimated the likelihood that the signals originate from an object behind Jumbo 24 and found it to be exceedingly slim, at just 1 in 10,000. And in case you were wondering, the signals probably don't originate from aliens. According to Rodriguez, The fact that both components emit at similar levels favors a natural mechanism. With the research at an impasse, the team is applying to the National Radio Astronomy Observatory's Very Large Array in New Mexico to collect data from free-floating planets. Until then, the radio signals will remain a mystery. Highest resolution gamma-ray image. While NASA's $10 billion James Webb Space Telescope grabs a lot of headlines, groundbreaking astronomical discoveries aren't exclusive to such high-tech tools. Take, for instance, the highest resolution photo of gamma rays ever captured, achieved without the need for advanced spacecraft or terrestrial arrays. This scientific feat was accomplished using a simple stratospheric balloon, layers of photographic film, and some ingenious engineering prowess. Late last year, scientists from Kobe University described the details of their experiment in a paper published in the Astrophysical Journal published groundbreaking astrophotography, focusing on the Vega pulsar, located nearly 1,000 light-years away. This pulsar, a type of spinning neutron star, results from the collapse of a larger star. It is a unique celestial object, measuring about 12 kilometers across and completing 11 rotations per second. Vega emits charged particles in various electromagnetic spectrum flavors, including radio waves, visible light, X-rays, and gamma rays. In October 2023, a study confirmed Vega as the highest energy pulsar known. Led by Kobe University astrophysicist Seiji Aoki, a team employed an innovative method using stacked photographic film and a stratospheric balloon to capture gamma rays. The film, sensitive to radiation, turned dark in the presence of gamma rays. Cameras tracked the balloon's position, and subtle shifts in film layers provided precise timestamps. The resulting image, 40 times higher in resolution than typical gamma-ray telescopes, unveiled 7 million tracks from Vega's gamma rays. In another release, the first data from the eROSITA All-Sky Survey Catalog, the largest catalog of high-energy cosmic sources, was made public. It covered half the sky over Earth, identifying almost 1 million sources, including over 700,000 supermassive black holes. The survey also revealed cosmic Webb filaments connecting galaxies and clusters, showcasing the instrument's capability. Operating for 6 months, eROSITA surpassed decades of X-ray astronomy, contributing to over 250 scientific papers. A separate investigation focused on asteroid samples returned by Japan's Hayabusa 2 mission from the asteroid Ryugu. Researchers found melt splashes, created when cometary dust struck Ryugu's surface, containing small carbonaceous materials resembling primitive organic matter. This adds to the evidence supporting the idea that comets delivered organic material to Earth. The report shifts to exoplanets, highlighting the discovery of TOI 715b, a super-Earth orbiting a red dwarf star. Its tight orbit allows frequent transits, making it an ideal target for study. The Transiting Exoplanet Survey Satellite, TESS, detected TOI 715b, contributing to the growing list of potential